Hello, everybody. Welcome to MTV.
Welcome to the Deep Dive. Today we're looking under the hood at how cutting-edge conversational AI, think Google's Gemini, is actually built.
Yeah, it's pretty fascinating stuff.
Our goal here is to give you a shortcut, really, to understanding the tech behind these interactions that feel, well, surprisingly human. Get ready to be well-informed.
Definitely. And conversational AI isn't just simple chatbots anymore. We're talking systems that process, understand, and generate really complex human-like dialogue. Think multi-turn conversations.
And the engine driving this, that's the large language models, right?
Well,
LLMs.
Exactly. They're the foundation. Sophisticated deep learning models trained on just massive data sets. We're talking trillions of words sometimes.
Trillions. And large refers to the parameters, doesn't it?
Yeah.
Billions, maybe even trillions, like tuning knobs.
Precisely. Think of it like that. More knobs mean more flexibility for all sorts of language tasks, summarizing, translating, you name it.
Okay, so what's the architecture holding all this together? I keep hearing about the transformer.
Right, the transformer paradigm. It's a type of neural network that was a game changer. Unlike older models that read word by word, transformers process chunks of text in parallel, much faster.
But wait, if it's parallel, how does it keep track of word order? Wouldn't hot dog become dog hot?
Ah, good question. That's where positional encoding comes in. It basically adds a little tag, like a coordinate, to each word telling the model its position. So order is preserved.
Got it. And then there's attention. That sounds important. The secret sauce.
It really is.
Yeah.
Attention mechanisms let the AI focus on the most relevant parts of the input text for whatever it's doing. Self-attention specifically gives it the sort of holistic view.
Holistic how?
It can see how words relate to each other, even if they're far apart in a sentence. Crucial for fluency and for figuring out words like bank. Does it mean riverbank or money bank?
Context, right.
Makes sense.
Yeah.
And multi-head attention is just more that.
Kind of. Multiple attention layers working in parallel, giving it an even richer grasp of the context. So a lot of the big names, like GPT, use a decoder-only approach. Why is that?
It's particularly good for generation tasks. Predicting the next word or token is its specialty, which is perfect for generating those flowing, open-ended conversational responses.
Okay, architecture sorted. But you need data. Lots of it. What kind?
High-quality, really diverse conversational data is key. Chat logs, call transcripts, social media stuff, things that capture how people actually talk, informal, messy, context-heavy. That's how you get that genuine feel.
And training isn't just one step, is it? It's multi-stage.
Absolutely. First, there's self-supervised pre-training on that massive raw data. Learns the basics of language. Then supervised instruction tuning teaches it to follow specific commands, be helpful.
And the final stage, RLHF reinforcement learning. Learning from human feedback. This sounds crucial for alignment.
It's the most critical stage for making sure the AI aligns with what humans actually want. People rate the AI's answers.
Like thumbs up, thumbs down.
Sort of, yeah, but more nuanced. This feedback trains another model, a reward model, which then guides the main AI towards being helpful, honest, and harmless. It's how you bake in human values.
Okay, so the AI is trained. How does it handle a real conversation? NLU, natural language understanding, figures out what I mean.
Yeah.
But how does it remember what we said 5 minutes ago? Aren't LLMs stateless?
They are, fundamentally. That's the big reveal for many people. The illusion of memory is managed externally.
Externally.
The app you're using or some other system keeps feeding the conversation history back into the prompt for the LLM with each new turn you take. It's constantly being reminded within its context window limit.
Whoa. Okay, that is an aha moment.
Yeah.
It doesn't remember, it's reminded. So things like RAG, retrieval augmented generation, help here too.
Yeah.
Fetching outside info.
Exactly. RAG lets the AI pull in relevant facts from databases or the web to make its answers smarter and more current. And then for generating the reply, an LG, natural language generation, kicks in, guided by prompt engineering.
Right, crafting the right prompts. And Gemini uses chain of thought. Like it thinks step by step.
Precisely. It allows the model to work through a problem before giving the final answer, making it more like a steerable tool, an analyst, a researcher you can guide.
Now, what makes Gemini feel particularly next-gen?
It's got to be the multimodality. It was built from the start to handle text, images, audio, video all at once, fused together.
So could watch a video and comment on it?
Yeah.
Or generate a recipe from a food picture?
Yes, things like that. Much richer interactions. But challenges definitely remain.
Like hallucinations, making stuff up.
That's a big one. Also, biases learned from the data and sometimes forgetting old knowledge when learning new things. They still struggle with perfectly natural spoken tone sometimes, too.
So it's not a one-and-done build. It needs constant work.
Constant polishing. That's where MLOps, machine learning operations, comes in. Continuous monitoring, evaluation, retraining. It's an ongoing process to keep the gem shining.
So wrapping up, what does this all mean for you listening? Building AI like Gemini is this huge undertaking, massive data, complex architecture, and that vital human feedback loop.
It's not just code that talks. It's about simulating understanding, managing memory cleverly, and this constant effort to align with us.
Which leads to our final thought for you. Knowing a bit more about the gears turning behind the scenes, how might your interactions with AI change? What new possibilities does that spark?